RIBA Sustainable Outcomes' main objective is to make sustainable architectural design simple enough to be applied on a regular basis to projects of all sizes. A sustainable building supports not only environmental sustainability, but also economic sustainability in terms of operating costs, and social sustainability in terms of health and well-being. They can be assessed using widely accepted techniques for building evaluation. They are rigorous and substantial, based on cutting-edge knowledge in the field, and expressed in an interdisciplinary global language of research to promote engagement across industry and academia, across disciplines, and across cultures. They also adhere to the guidelines set forth in the Treasury's Green Book and the Ministry of Housing, Communities and Local Government, MHCLG, of the UK Government. It demonstrates the various levels of the outcomes-based approach and how they relate to the triple bottom line of sustainable development. Each outcome, along with the key performance metric, set of design principles, and verification requirement, is clearly stated and categorized under the relevant environmental, social, economic, or multiple categories. Each outcome has a single key performance metric to make it easier to use. However, some outcomes are incredibly complex, necessitating the use of supplementary, but complementary metrics to produce a full picture. Environmental factors like daylighting, air quality, and other factors that affect indoor health are included. Furthermore, rather than advocating that the results should be viewed as distinct silos, it's critical to highlight the connections between the results. For instance, under the concept of whole life net carbon, the UKGBC's Net Zero Carbon Buildings. A framework definition, 2019, and RICS's Whole Life Carbon Assessment for the Built Environment, 2017, both define net zero operational carbon and net zero embodied carbon as twin targets. RIBA Sustainable Outcomes Metrics target net zero for new buildings and retrofit buildings. 1. Net zero operational carbon dioxide emissions, kilowatt-hour, M2, Y and kilogram CO2, E, M2 year. The carbon dioxide generated as a result of the production and use of the fossil fuels used for the buildings or structures' daily operations, including low or zero carbon renewable energy technologies both on and off-site, as well as recognized offset schemes where necessary. According to Passivhaus PPHP, or CIBS-TM 54 evaluating operational energy use of buildings at design stage, 2013, as the primary definition. Target, net zero for new buildings and retrofit buildings. 2. Net zero embodied carbon dioxide, kilowatt-hour, M2, Y and kilogram CO2, E of floor area M2. The carbon dioxide generated by the energy used in the extraction, fabrication, and transportation of the building materials from their original locations, including recognized carbon offset programs. According to RICS Whole Life Carbon Assessment for Built Environment, 2017. Similar to operational carbon dioxide, the amount of mains water used in the operation of the building includes the offset by use of recycled or grey water to cut back on mains water consumption. Building Regulations Water Calculator, primarily modeled after England and Wales. Target, to achieve 40% reduction in potable water use per person per day. 4. Sustainable connectivity and transport, kilogram CO2 e per kilometer per person per annum. The goal of this outcome is to quantify the carbon footprint of travel by site, or building occupants and visitors to and from a nearby transportation hub, local retail establishment, or neighborhood facility. As principally defined by BREEAM 2018 transport credits. Target to achieve net zero carbon emissions per person per day. 5. Sustainable land use and biodiversity, increase in new flora or fauna species on site. The goal is for this result to be used as an indicator of how well the site's flora and fauna are being maintained, protected, and improved. According to the London Plan, Urban Green Factor, and BREEAM 2018 biodiversity credits, in particular. Target to achieve net positive species impact and 0.3 to 0.4 urban green factor on all new sites. 6. Good health and well-being, various metrics. This outcome takes into account important factors that affect the health and happiness of the occupants inside the building, such as indoor air quality, daylight, overheating, acoustic comfort, responsive controls, and direct physical contact with the outside world. According to the 2019 Well Building Standard V2 Preconditions and/or Good Homes Alliance Overheating Guidance, which are primarily defined by CIP's TM 40, 52, and 59. Target to achieve good indoor health metrics as per 2030 challenge, including CIP's TM 40, TM 59 overheating avoidance. Sustainable communities and social value, various metrics. The objective of this outcome is to evaluate the positive effects of effective placemaking on a neighborhood community. The main definition, as of 2019 according to the RIBA Social Value Toolkit. 8. Sustainable Life Cycle Cost, pound of M2. The goal is to use the government's soft landings requirement for measuring building operational costs in order to ensure a comprehensive result in terms of economic sustainability. According to the 2019 edition of the ICMS Global Consistency in Presenting Construction and Other Life Cycle Costs. In conclusion, Consumer Trading Organization Limited will be hosting more concepts.